now have our dear colleague, Dr. Andrew Edwards, who's going to tell us about some other pretty exciting fire severity mapping that he's been doing for quite a few years. Sorry.
Okay. So as Jeremy said, we've been doing this for quite some years. I've been working with a colleague who's with the Darwin Centre for Bushfire Research, Dr. Patrice Webber, who's not only a pretty amazing ecologist, but a wonderful software programmer, and he's been doing a lot of the satellite image processing for this project. I'll go pretty quickly because according to the time, I've got 2 minutes left. But I just wanted to say, look, the region we're looking at, for those of you who don't know, is this northern part of Australia. It's about 25% of the continent. The continent's about 7.7 million square kilometres. This region we've been looking at is about 2 million, a bit under 2 million square kilometres. So pretty big. So the mapping that we do, we use the MODIS 250 metre pixel red and near infrared bands to do the mapping. It's done on a kind of a weekly basis, depending on how much fire is going on. And this is fire frequency for a period of 21 years. And you can see there's a lot of fire going on all the time. So, you know, because of that, the Savannah burning method was instigated. And what's really amazing about it is that there was this real fusion from the very, very beginning of traditional Indigenous land management knowledge and where and how and when to burn, fused with all the scientific information from researchers across the top end, from our group, from the CSIRO, and many, many, many others. So, you know, that is the beauty of this project, is that it does come. The fire management that's there has come from a lot of consultation and a lot of work together. The first determination became law in 2012 as part of the Australian Government's Emissions Reduction Fund. And as I said, it uses this 250 metre pixel data that Peter talked about before, that is then incorporated into this other calculation tool called SAVBAT, which was developed by colleagues of ours in Melbourne, based on all the work we'd done to create all the background calculations. So it's a pretty straightforward system. It's very transparent, it's very easy to see, and it's very easy to use. This SAVBAT tool is very, very easy to use. This is the extent of savanna burning projects in the tropical savannas. So that green line is the boundary of the savannas I mentioned earlier, and all those blobs of sort of khaki, the project area. So it's pretty extensive. You can see that area in the middle at the top, that sort of head-shaped thing in the middle is the top end of the Northern Territory, and that big blob of stuff is pretty much all of Arnhem Land that's covered by projects. And then very similarly over in the North Kimberley to the west there, a bit below and to the left, that's Western Australia, and I didn't do that. And a lot of that area is covered too, and they're mostly Indigenous owned project areas. Quite a large number of all these projects are on Indigenous land. So then we come to this, the issue. One of the big issues that we've been facing with this fire mapping is, and all the methods that we developed is this idea of seasonality. So we've all been talking about early dry season and late dry season for days and days, but you know, it's not consistent all the time, every year and in every place. And that's a big bone of contention. And it's why we started this project to develop fire severity mapping quite some time ago. And so for many, many years, we set out to collect a lot of data in the field, because you can look at a satellite image and you can quite clearly delineate a fire scar without too much trouble. If you're expert, if you're good at playing with satellite images and doing all the stretching and that kind of thing, and have some knowledge of what the country looks like and what a fire scar might look like, you can do it quite well. But fire severity is another thing again. I mean, it's very rare that people are able to describe the fire severity from a satellite imagery or even aerial photography. It's very quite difficult. So what it does take is a lot of ground observation, and then using that to calibrate to some sort of index or something using the satellite imagery. So this is some of the calibration data that we've been using, and it's quite extensive. So this model is very, although it's a top-down thing using remote sense data, it's based on a lot of observational information yet again. And a part of that, a part that supports that, the idea of what fire severity is in the landscape are these very extensive plot networks that we've had throughout the 3 biggest national parks in the top end of the Northern Territory, and that all those other plot data that Brett very kindly showed before, all those crosses he had on the map that are right across the area. So this is a sort of a conglomeration of these data. The one on the left is some work that Jeremy did in the early 2000s. I think that paper came out, and it was about 10 years of data. It was just looking at plots that have been burnt in the early dry season versus plots that have been burnt in the late dry season. And he assessed all the photographs for all the years that these plots have been burnt and photos have been taken, and came up with these numbers here. So you can see that bar on the far left, that shows that in the early dry season, we have a very small number of high severity fires, a little bit more, maybe a bit less than 20%, moderate severity fires, but the majority of them are low severity fires. But then you look at the late dry season and it's quite different. So it's this proportionality that we really need to describe when we want to do some produce a fire severity mapping product. And then that those graphs on the graph on the right with all those bars, that's a lot of the data that Brett referred to before that our colleague Peter Whitehead put together. We had all these hundreds of measurements, but they were pretty messy. So he spent many, many months cleaning the data up and came up with this graph. And you can see it's pretty similar to what the graph on the left, but obviously there's a fair bit more nuance looking at every month. And you can see the sort of incremental increase in the severity of fire as the year goes on. So that's what we know. And then looking at it, as I said before, we know that there is quite a bit of geographical variation in that cut-off date between what's early and what's late across Northern Australia. There's this sort of drying phenomenon from west to east that occurs. And so in my initial assessment of the hotspot data to try and describe that, and it's been done before by colleagues by Stefan Meyer quite a few years ago, but we've got quite a bit more of this hotspot data available now to make analysis a bit more statistically robust. So if I break it up into these sort of 3 zones, so that WA zone, which comes over just past Darwin, and you can see in that graph at the top right, so that red line in the middle is where the ratio of daytime to nighttime hotspots is equal. And where the point falls below the graph, that's where we've got many more nighttime hotspots. So if a fire is occurring at night, you can be pretty sure that it's running continuously. And that's kind of a wildfire, which is what we're sort of our vague description of what a late dry season fire is. So you can see where that ratio changes. So in the early months of the year, it's up well above the equal number of hotspots, day and nighttime hotspots. But then we reach a point in July, usually around mid-July, late July, and you can see there that it quite clearly delineates this period where you would expect the severity to start to increase. So we've got these data to sort of indicate where these cutoffs should be. So then what we did was we developed algorithms. We developed different algorithms for those 2 different periods. So when the cutoff, when the ratio changed, we went, all right, we'll go and re-look at all the data, the calibration data, and we'll change it and create a new algorithm for that time period. So we end up with 6 different algorithms for any given year. So one for the west, one for the mid, and one for the east, and then for early and late, or before and after the cutoff period, the threshold. So we're just trying to fine tune the initial version we did of this was just sort of one algorithm for the whole year, but now we've broken it up into 6 periods just to make it a bit fine. So this is the big processing flow chart. It's pretty heavy. It's very pretty, I think, but it's very it's very heavy. But basically, we use the mapping that our the very accurate NAFI mapping that we know is about 95% accurate. And then from that, we can mask the imagery. So we're not looking for severe fires outside of an area that was burnt. That's a pretty good way to go, and that limits the amount of data that then needs to be processed. And we use this algorithm, the relativized difference in the near infrared, which is basically looking at an image pair before and after the fire in the near infrared, and then doing these calculations and adding it all up, applying the algorithms for the 3 different time periods for the 3 different areas, and doing the classification based on all those calibration points that I mentioned earlier, and doing a classification and coming up with a fire severity map. The hotspot surface is probably the real innovation in all of this, I think, as well as obviously having a really cool fire severity map. These hotspot surfaces that Patrice put together are basically, so he's gone and got all the hotspots, which if you look at those data, they're quite spurious. They're just sort of indicative of where fires have been. They're not a good map of where fires have been all the time, unlike the burnt area mapping itself. And so what he's done is he's gone and used the hotspots to try and attribute, because what we want to know is when a pixel burnt, what day did it burn? Because we're not collecting, we're not mapping fires every single day, because we can't, because there isn't imagery available. The hotspot, we're using those hotspots, we can kind of extrapolate very closely within about plus or minus 1 day, and we can describe the date that every single pixel got burnt. And then that way, when we do this big annual image mosaic, we're able to work out what image pair is best to use before and after the fire occurred, because that's actually pretty problematic. It's been a bit of a problem for us throughout the years to do that. There's the algorithm. I described it a minute ago. It uses all these various image pairs. It's a bit heavy. We'll skip that. So anyway, we end up with a fire severity map. So you can see there, I've just got it in the 2 colors, severe and not severe. So there's red stuff and there's green stuff, and you can see, at first glance, when you first look at this, you can see that it makes a lot of sense, because all the little patchier fires that you can see that would have occurred in the early dry season are predominantly low severity, and it's only the bigger patches where you get a lot of high severity stuff in there. So yeah, there we go. That's the fire severity map.
Just like one extension to that is that map then can be fed into the modelling that Brett has just described to actually do the calculation of the emissions from fires based on fire severity across the landscape. So it's a pretty sophisticated coupling of decades of work. We do have time for a question or two if anyone wants to ask of Andrew something pressing.
Oh, thought I was running really late.
Hi, I'm Rick Anderson. I do some amount of this work, and I was wondering, and I appreciate your comments about its need for ground truthing. Do you use the composite burn index with your ground truthing? Or
No,
something similar?
No, the CBI, yeah. I mean, we have looked into that, and very early on when I was doing very detailed versions of the mapping, and that paper that Brett referred to earlier, where we looked at the extreme fires, I did use the CBI because it was a very small area, and I could collect a lot of data and do some really incredible calibration by doing that. But all of those data, excuse me, because we're mapping such an incredibly large area, I want to get as many points as I can. It's all helicopter based primarily. So I'm flying in a helicopter and I'm estimating the scorch height primarily is the easiest thing to discern, and estimating the scorch height and how much of what proportion of the vegetation has been affected, primarily the canopy. So because in those savanna, I didn't put any photos up, but in the savanna systems, you've got a tall tree, and then you've sort of got grass, continuous grass with scattered trees, and you can quite clearly see if a fire has been affected. Sorry, if the canopy has been affected by a fire. Yeah, yeah. I mean, it's great when you're just looking at one small area, like, in Southern Australia, it's very appropriate, as it probably is as I know that it is in many US situations, but in this enormous landscape, absolutely smothered in fires, you'd be there for 100 years collecting enough data to be useful. So that's where the helicopter surveys are.
One quick question.
Yeah, thanks. How does the algorithm or the program treat the difference between a fire that may have happened at nighttime but under a cool burning regime, because a lot of the rangers we saw this week undertake activities in the dark, versus the assumption that it could be a wildfire and therefore a high intense fire?
Well, it's based on the change, on how much it's changed. So if you have burnt at night and it is a low severity fire, then it will classify it that way. So you end up with this. You do end up with, in some spaces you can see where a fire has moved across the landscape because it's gone from low to high severity as it moves. Yeah, it's an interesting and very good point. Cool.